Hi, today we're going to go over lesson 6.1 over polygons. Now, first of all, let's go over the definition. A polygon is a two-dimensional figure. It is closed, made of segments, and it intersects segments only at the other segments' endpoints. So we're going to go through and explain why the answers are what they are for the next section. For the first one, now, it does say it's two-dimensional, so that means it can't be a three-dimensional shape, which, as we know, like cubes and boxes and, things like that. So the first shape, it is two-dimensional, which means it is a flat object. It is closed, which means all the sides come together and touch. It is made of segments. So the answer is yes, it is a polygon. Now, the second one usually fools people because they say it's flat, it's closed, but does it have segments? It doesn't. It's a circle or oval. So the answer is no, it has no segments, has no sides. Now, the third one, again, is a tricky one because usually people go through the list. It's closed, it's made of segments, but the very first thing, is it two-dimensional? No, it needs to be two-dimensional. Now, number 4 is usually the trickiest. Notice how I have the arrow pointing up. It needs to only intersect at the endpoints. So if I could erase this part in blue, if I would only look at one triangle, it would work. So the top triangle works, the bottom triangle works, but as a whole, this does not work because right there in the middle, they intersect and they should only touch at the endpoints. So again, if you only had the one triangle, it would work. If you had the bottom triangle, it would work. But as a whole thing, it does not work. Now, the last one, notice they don't touch. So it means it's not closed. And so again, it's not a polygon. So to name a polygon, you list the consecutive, that means one right after another. You don't jump around the consecutive angles. So concave polygons, what it says here, it says it has an interior angle greater than 180. Now, guys, you've done this before. Concave is where it caves in. And what it's saying about greater than 180, like this angle, like if you look at it from this viewpoint, that angle is greater than 180. Okay, so does it cave in? Yes, it caves in right here. So it is concave. Now you would have to count the number of sides. There are 8 sides here. I've already counted it out. So this is an octagon since there are 8 sides. Okay, so the next one, it is called convex, which means it doesn't cave in. Now this is a nonagon. How many sides does a nonagon have? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Any 9-sided polygon is called a nonagon. Okay, next one, it does cave in here. So this is concave, and there's 1, 2, 3, 4, 5 sides, so it's a pentagon. Equiangular. Okay, the word equiangular means all the angles are congruent. And equilateral means all the sides are congruent or equal. So when you put those two things together, you get regular. And regular means all the angles and all the sides are equal. Okay, so on the next part is, and I'm not scrolling because I don't want you to see the answer. It says draw quadrilaterals, so that's 4-sided shapes that are equiangular, but not equilateral. So they have equal angles, but not equal sides. The next one is equilateral, but not equiangular. So all equal sides, but not equal angles. And the third one, you're going to find and draw a picture that has all equal angles and all equal sides. So pause the video, try it, see how you do. Okay, hopefully you're back from trying this. Let's see how you did. for the first one, all the angles are going to be the same, but not the sides. So I know it kind of looks like a square, but we don't know it's a square because notice I don't have any congruent marks on it. So if you made yours look more like a rectangle, that's probably even better. But, as long as, I could even do this. That proves the sides are not all equal, but the angles are equal. On letter B, all the sides are equal, but the angles are not. And then on letter C, this is a square. All the angles and all the sides are the same. Okay, so the question here is, let's find the sum of the interior angles. So from one vertex, and you can pick any vertex, how many diagonals can you draw? And obviously, I drew 5. Here's how I figured it out. 1, 2, 3, 4, 5. Now that created 6 triangles. And so if there's 6 triangles, we know triangles are 180 degrees each. So if I take 6 times 180, I get 1080. So that's how many degrees that are inside of the polygon. So we can make a formula out of this. What we can do is we could say, now, how many sides does this have? This has 8 sides. This is a octagon. So here's how I'm getting this. If I'm timesing by 180 and I have 6 little triangles, that's 2 smaller than the number of sides. So if you look down here at this equation, I'm taking the number of sides, which is n, I'm subtracting 2, and then I'm timesing it by 180. Now this is going to work every single time. You just take, again, the number of sides, subtract 2 times 180. It keeps you from having to draw the picture out and draw the diagonals, and it's a really good time saver. And we're going to practice this in just a moment. Okay, so if a polygon is regular, regular again means all the angles and all the sides are the same, then the measure of each angle is the measure of the sum, which means all of them added together, of the angles divided by the number of sides. Okay, we're going to practice this. Don't worry. Okay, so for a pentagon, you need to know that's 5 sides. So I'm going to take 5 and subtract 2, because that's my formula, and times it by 180. So this is the sum. Now, I'm just saying if. If all the sides and angles are the same, if it's regular, and I say, tell me how many degrees each angle is. So I would have to take 540 and then just divide that by 5. So 540 divided by 5 is 108. So this is each angle. This is the sum. This is all of them added together. Okay, quadrilateral, that's 4 sides. So I have 4 sides and I subtract 2. So 2 times 180 is 360. Now, how do I find each angle? I'm going to take 360 and divide it by however many angles I have, and I have 4. Or you could say how many sides you have, either way. And so when I do that, I get 90. All right, the next one is 27. I mean, you definitely don't want to have to draw this out. A 27-sided polygon. 27 sides, subtract 2 times by 180, and you get this big number, 4,500. Now, what if I wanted to know what each angle was? Now, this is only if it's a regular polygon. I would divide by 27. Okay, divided by 27. Now this one, I mean, you would have to round off. I get 166. I want to round it to 0.7. So as you can see, it's really not that difficult. Okay, so then find the measure of one. That's the key. One angle. Okay, so there are 5 sides. So I didn't show all my work here. So it's 5 minus 2 times 180, which is 540. And then I take the 540 and divide it by 5 to get 108. On letter B, I take the total 18, I subtract 2, times it by 180, and then I'm going to divide by 18 since I have 18 sides. So these are the degrees of the one angle. All right, so just ignore this. I was trying to show something and took the class that we're just not going to worry about today. Okay, so the sum of the angle measures of a polygon with n sides is 900. Find n, which is the number of sides. Okay, so what am I doing here? So I just wrote the basic equation. The number of sides, and you subtract 2, and you times it by 180, and then it equals the 900. And I get the 900 straight from the question. So there's a couple of different ways to solve this. One, you could distribute the 180. But what I chose to do is I divided both sides by 180 just to get rid of it and to put it on the other side. So what am I left with? I am left with down here n minus 2. And when I divide, 900 divided by 180 is 5. And then I add 2 to both sides, and I get n is 7. So n is the number of sides. Okay, so on the next one, I'm just trying to find the missing angle. So there's some prep work here before we just jump in. There's 1, 2, 3, 4, 5 sides. Now we've already found this total someplace else in the notes. We'll try it again. How do you know how much the entire angle equals? Well, you take 5, you subtract 2, and you times it by 180. And if you type that in, you should get 540. So I know my total's 540. Now, all these little angles, I'm going to add them up. Now, of course, there's an X, and here's all the little angles. Now, let's combine like terms, and let's add the 124, the 100, the 100, and the 10, or the 118. And I already did that for you, and I get 442. And I just bring down the 540 and the X. So I'm going to subtract the 442 to the other side. So just grab your calculator and subtract. 540 minus 442 is 98. So the missing angle is 98. Now, is this pentagon regular? Are all the sides and all the angles the same? Now, don't let my little symbols here confuse you. Those I just used for counting. Those do not mean congruent. They are not the same because I know this because all the angles are different. So if the angles are different, it means the sides are different. Okay, on the next one. Now you may already know this. When you have a four-sided polygon, what degree measure does that equal? Okay, so let's say you don't know that. So 4 minus 2 times 180 is 360. Okay, so this is your total. We can always find the total pretty easily. So let's take your total, 360. Now let's take these four angles and add them together. So 2x, 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 and 2x is 8x. And then I have a 20 and a 20, which is 40. So let's solve, which means subtract 40 from each side. And I get 320 and bring down the 8x. And when I divide by 8, I get 40. Okay, so let me go back and read these directions. It says find the angle measures. Now, I got to tell you, I didn't finish this question when I did it in class because 40 is not the angle measure of every angle. What I need to do is plug it back in. So 2 times 40 plus 20. So 80 plus 20 is 100 degrees. Okay, so I know the opposite one here's 100 because they have the same equation. And then 2 times 40 is 80. And 2 times 40 is 80. All right, so we're finished. We found all the angles. Okay, so sometimes kids don't know some vocabulary of like what the names are of the polygons. And so here's a list, and study these as you need to. You will be expected to know what all of these shapes are. So we can quickly go through and maybe draw a picture of them. Now, a quadrilateral is any four-sided shape. So I can't really draw every four-sided shape for you. So just know it's any four-sided shape. A kite. So I'm going to draw the kite up here. A kite is like an equilateral triangle on top and then a different equilateral triangle on the bottom. So it really looks like a real kite. So the way I always remember is like it's equilateral triangle on top, a different one on the bottom. A trapezoid. Okay, a trapezoid has one set of parallel lines. So it usually looks like that. Now, a isosceles trapezoid has two equal sides. So you would have to know those two sides are equal and you have a different set that is parallel. For a parallelogram, just opposite sides are parallel. The way that I showed this is by putting my parallel symbol. That's a parallelogram. Okay, rectangle. We know rectangles. We know opposite sides are equal and they have right angles. Those are all right angles. And technically, these opposite sides are equal and parallel. Rhombus. A rhombus is like a parallelogram, but it has all equal sides. It's kind of like a square that's pushed over to the side a little bit. Okay, so all these sides are parallel, but like opposite sides are also equal. And lastly, square. You guys know what a square is. All equal angles, all equal sides. There's a square. All right, so here I always call this like the family tree of the quadrilaterals. Okay, so this is actually very helpful, and we're going to use this the entire chapter. So we start out with the quadrilateral, and it breaks into three families. We have the kite family, we have the trapezoid family, and we have the parallelogram family. Now, once you're in the parallelogram family, we have another branch. It's either you're going to deal with all the angles being equal or all the sides being equal. So if all the sides are equal, it's a rhombus. If all the angles are equal, it is a rectangle. Now, when you put those two together, when you put a rhombus and rectangle together, it makes a square. So a square is head shape. It's like king, because a square technically is a rhombus, and a square technically is a rectangle, and a square is technically a parallelogram and quadrilateral. So if you notice down here at the bottom, I say always and I point up. So whatever the shape is, everything above it is that shape. So if I would say, is a parallelogram a square? You would say no, because not all parallelograms are squares, because it could be a rhombus or a rectangle. So because you're going down the tree, it's a no. Or actually, it's not always. If you're going up the tree, it's always. So the way it works is side to side is never. So a parallelogram is never a trapezoid or never a kite. And if you're going down the tree, it is sometimes. So I would definitely jot this down. It's going to help you tremendously. Now, the answers are here, but we're using the chart. Okay, so is a parallelogram a kite? No. I mean, they're in opposite parts of the tree, so it's no. Is a quadrilateral a trapezoid? Well, it could be. It also could be something else. So it's a sometimes. Is a rectangle a square? Well, maybe sometimes. Is a square rhombus? Remember, squares head shape, so that's a always. Is a parallelogram a trapezoid? Is a parallelogram a trapezoid? Now, notice they're in different parts of the tree, so it is a never. Now, I accidentally had the same question on here twice, so I just flipped it. Is a trapezoid a quadrilateral? And that is always, because it's going up the tree. Now, I tried to fool you. Are triangles even in the picture? No, because they're not a four-sided shape. Of course, it's never. And is a square a trapezoid? Now, I know squares head shape, but it's only head shape in that family. So trapezoid's not in the same family, so it is never. Okay, so we are going to identify using markings. The first one, opposite sides are parallel, so it is a parallelogram. Now, if you look at the next one, notice the left and the right side look like isosceles triangles. This is a kite. You have one set of parallel lines, so that is a trapezoid. Now, if you're saying why isn't it isosceles, you would have to know these two little legs were equal. They are not equal on this example, so it is not isosceles. Now, when I taught this, my class said this was a square. Now, it kind of looks like a square, doesn't it? But does it tell you these are right angles? It doesn't, does it? So can we assume the right angles? No, we can't assume anything. So it is not a square. It is a rhombus. Let's go back to the tree. A rhombus has all equal sides, and it's right here. So yes, they are going to try to fool you. Like this one, they're trying to fool you. Now, the picture definitely does not look like a rectangle, but they tell you these angles are 90 degrees. So go by the information. If the angles are 90 and the opposite sides are equal, then it has to be a rectangle. All right, so we're done. Let me know if you have any questions. Feel free to sign up for a tutorial. Thanks a lot. Bye.